So here we can see the radiation lab simulation. Whether you're doing this in real life or using a simulation, the equipment in front of you will be similar. You'll have your GM tube or other type of detector, some kind of counter setup, your sources that you're going to be wanting to make sure are safe and secure, and different types of shielding material. This demo I quite like, this simulation I quite like, just because you can see that the sources are all in their lead line boxes, and you also have a key to the store cupboard. So there's a whole process involved in getting the sources in and out to make sure that you are using them safely and securely. Also, the detail is quite nice in that you have to turn the counter and the GM tube sort of on at the wall as well, which is quite nice. Okay, so firstly, when you are using your sources, make sure that your distance between the detector and the source is the same each time. So, and I'd recommend using quite a short distance when you're comparing the three sources, because obviously with the alpha source here, we're using American. It is stopped by air. So if you were to compare the count rate here, where the separation is quite small, you can see here with this counter, what happens is it's just kind of detecting the decay rate over a set period of time. And after that set period of time, you'll get a reading. So here we're getting a reading of around 73,000. If we were to then move this counter back, press the reset button, you can see that this count drops dramatically. It's not completely dropped, it's not gone down to zero. There's a good chance that this source is also giving out some beta and gamma, but you can see the difference that distance from the gamma tube does make. Anyway, so keeping the separation distance the same for all the different sources, what I'm going to do now is try the paper shield. Let's just try and reset this. And you can see with the paper, it's much reduced. So without the paper, we're getting a reading of about 73,000. That's dropped down to about 200, 300 in fact. So you can see that the paper is stopping a lot of that radiation getting through. There's still a little bit going through. Some of that might be down to the beta and gamma. So now let's have a look at strontium. Again, so strontium, you can see the count rates sort of going up here. There's a lot of activity with this strontium source. Is it giving off alpha? If it's to give off beta, if we were to put the paper source back here, restart the count, you can see it's not making much of a difference. So we know that this source is unlikely to be predominantly an alpha source. That it's going to be either beta or gamma given off here. If we put the aluminium up, there we go, and do this again, you can see the count rate has massively dropped. So we could probably say quite safely, this is going to be predominantly a beta source. So then the last one, what is this giving out? Again, let's, so with nothing at all there, what is the count rate? That's ticking over nicely, quite a nice high activity being even out there. Ultimately, you're looking at around sort of 12,000 being given there. If we were to put the, let's put the lead back for the moment, put the aluminium there and compare the two count rates. So last time we got a reading of about 12,000. We're getting about 10,000 now with the aluminium. I suspect actually what we've got there is gamma. And I've just put the lead shielding up there. That has now reduced it quite a bit more. And we are looking to get a count rate of about 5,000 there compared to about 12,000 initially. So there's going to be, this has got a lot of gamma radiation coming off it. Don't forget to lock your sources away at the end.